before this is due. And this first screenshot I'm looking at is from the purple packet. It's page 8A, and you can see up in the corner it's page 8A right here. Numbers 13 through 18 are absolute value problems, and you can see everything's represented, less than, equal, greater than. My only advice for doing 13 through 18, make sure that you have the absolute value isolated and cleaned up before you start trying to solve it. And to compare it, I'll show you looking at the self-test at the bottom of the page. See, the absolute value problems here are completely cleaned up. So you've got everything removed from the absolute value, so you simply have the absolute value equaling a number or an inequality symbol equaling a number. The problem set at the top, they have a little bit more clutter around them, so you just need to use inverse order of operations in order to clean them up and isolate before you start to solve. So just be careful with that. The problem sets 19 through 24. The abstract just require a little bit of thinking. Number 19, is the absolute value of a squared equal to a squared? That is a true statement. Absolute value always results in a positive number. And if I'm setting it equal to that same number being squared, that's also ensuring that I get a positive outcome. Now, if you can find one argument that makes a statement false, then you have to claim that the entire statement is false. So number 21, the absolute value of a over 3, does that equal a over 3 outside of the absolute value symbols? And that is a false statement. So I will just go with the example. What happens if a is negative 1? I would have the absolute value of negative 1/3, setting that equal to negative 1/3. Well, the absolute value of negative 1/3 would be 1/3, but that does not equal negative 1/3. And I will let you look at the others by yourself to come up with answers, true, false. And if it's false, make sure you provide an example. Number 25, a little bit of common sense problem with absolute value. I would simply take the formula and let C become 10, read the problem, and figure out how to answer that. And you can look at the other absolute value word problem video if that helps you at all with this. And then self-test number 2 is just a good recap of everything that you would need to have mastered for the quiz. So it's combining compound inequalities as well as the absolute value inequalities. And now I'm going to move to the book downloads, and I'm looking at page 485 from the book download, another problem set that you've been asked to do before we have class again. And these are fairly simple to do. The graphs, you're asked to write the absolute value equation that's being represented in the graph. I will look at number 7 with you. Find the center of the graph. So you've got your 2 endpoints. Just average those to find the center. Number 7 is centered at 0, and then I'm going 2 units in either direction of 0. So the equation that would represent this would be the absolute value of x. And since I'm including a range in between, that's associated with less than, but the 2 endpoints are not included, so it's a strict inequality. So the absolute value of x is less than 2. And you can run through these and see for yourself whether they're conjunctions or disjunctions. And then finally at the end, at the bottom, there are a few down here that are interesting. Just make sure that absolute value is always positive or 0. So the basic rule would be the absolute value of a number must be greater than or equal to 0. So it's okay for me to have something like 5 minus 5, because the absolute value of that would be 0. But it's not okay for me to have something like 4, the absolute value of 4 minus 5 is also equal to 4 minus 5. That would mean the absolute value of negative 1 is equal to negative 1, and that is not true. The absolute value of negative 1 is positive 1, and that does not equal negative 1. And absolute value cannot be negative. So just be careful when you work through some of these, because they do try to trick you in some way.